This question is from GATE 2018 Mechanical Engineering Paper Set 1, question number 55. An electrochemical machining ECM is to be used to cut a through hole into a 12 mm thick aluminium plate. The hole has a rectangular cross section 10 mm by 30 mm. The ECM operation will be accomplished in 2 minutes with efficiency of 90%. Assuming specific removal rate for aluminium as 3.44 into 10 to the power minus 2 millimeter cube per ampere second, the current in ampere required is dash. Let's find out. Let's write the given things first. So time t is given to be 2 minutes. Specific removal rate is given to be 3.44 into 10 to the power minus 2
millimeter cube
per ampere second, and efficiency is given to be 90%. We need to find out the current required. So first we'll find out the volume of material to be removed. So volume to be removed can be found out using the depth of the plate and the area given. So 10 by 30 are the dimensions of the plate and 12 mm is the depth. So we can write volume will be 10 into 30 into 12. This turns out to be 3600 millimeter cube. Now volume to be removed can also be given by the formula specific removal rate into the current into the time taken. Because efficiency is also given, we'll have to multiply this with the efficiency. Let's substitute the given values and find out the current I. I will be equal to 3600 divided by efficiency is 90%, which can be written as 0.9 into specific removal rate 3.44 into 10 to the power minus 2 into time. But time is given in minutes, so let's convert this in seconds. 2 into 60. This, when calculated in digital calculator, gives us the current as 968.99 ampere. Let's go back and fill in this answer. So all this data given, the current that is required is 968.99 ampere. To learn about electrochemical machining in detail, you can refer to the NPTEL video Lecture 38 Electrochemical Machining. This lecture is from the course Manufacturing Processes 2. The course is taught by Professor A.B. Chattopadhyay, Professor A.K. Chattopadhyay and Professor S. Paul. They are from Department of Mechanical Engineering of IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.